It is officially 7:33 and we are up to 14 participants. If you would like to call the meeting to order.
Yeah, let's do that. Let's go ahead and call the meeting to order.
It's a meeting.
All right. I'm gonna go ahead and momentarily share my screen, which is here.
Make that 15.
All right. So welcome to our first meeting of 2023. I have gotten used to writing that on my checks, so I guess that's a good thing.
You're not in slideshow mode.
No? Oh, hang on. There we go.
There you go.
Okay. January 18th. Is that today the 18th? Yeah, January 18th. Okay. We're going to go ahead right into our speaker, who's Chris Erickson, Hawaii Astronomy Club. And Chris, I'm going to let you go ahead and do the synopsis of your presentation, because I just went ahead and did a copy paste from your email, which we did send out to everybody. But I'm going to go ahead and stop sharing.
I made that all up myself, Chris. So
okay. All right, so you can go ahead and take over.
No, well, I'm going to just turn it right over to Mr. Erickson and let him take it from here.
Yep.
He's much wiser and smarter than I am, so let's just leave it at that.
All right. So Chris, it's all yours.
Again, everyone, please mute themselves, and you can unmute for question when you like.
Okay, guys. Hi. Like I said, I'm an engineer. I lived in Alaska for quite a few years. I retired 14 years ago. At age 50, I moved to Hawaii to play and scuba dive and grow bananas and generally goof off and enjoy astronomy. And then I got bored and I decided to hang my shingle back out and now do some small projects for the observatories. Well, it turned out there was a big demand for engineers with experience with doing telecommunications and robotics and so forth in extreme environments. And suddenly I was much busier than I ever had been before, but this time was with projects that I loved. And so I've been doing quite a bit of consulting engineering in Mauna Kea and Mauna Loa. And then some years ago, I was attending a talk at the Keck Observatory. One of the visiting astronomers was wrangled into giving a talk about occultations. He'd come to the Big Island to do Pluto occultation. And it was a fun presentation, much better than what I'll ever be able to do. And afterwards, we're talking and got a little bit technical about equipment and telescopes and so forth. And he asked if I would ever be interested in traveling the world and participating in these occultations for NASA and SWIRI. I said, well, that sounds pretty cool. Well, I'll be interested in that. And so I've been involved in occultations ever since, and it's been a lot of fun. And what I want to do tonight is share a little bit with you guys about occultations. And if any of you decide you want to do the same things I'm doing and meet out on the road and travel the world and have fun doing all expenses paid expeditions to crazy parts of the world, that I hope to see you do it. And so what I've done here is I've taken some images of a more recent expedition that I participated in to Australia. I've been to Australia, New Zealand, Spain, several times Argentina, and other places doing occultations, including a number that I've done on my driveway for NASA, which has been pretty cool. Anyway, I took my pictures and the different data that I had from this occultation to Australia for New Horizons, NASA, and decided to throw together a presentation. I wasn't planning on doing a presentation when I was on the expedition. And so it took me a little bit more work than usual to collect all the pictures I wanted and the diagrams I wanted and to put together this presentation. I'll warn you, it's 75 slides, basically 75 pictures. And we could whip through them pretty fast, or we could stop periodically for questions. It's up to you. I'm happy to answer any questions you have. This talk is not a real serious talk. I try to explain some different things at sort of a higher level. There's no math involved. There's no test afterwards. So we're all grateful to hear that. Anyway, with no further ado, I'm going to go ahead and share my screen if I can, and we'll start the presentation. Okay, can you guys see that okay?
We have it, yes. Thank you.
All right, okay. The picture you're seeing is my partner on this particular expedition. He was a young man. He was a student at one of the universities. One of the things that SWRI does, they try to take advantage of all of the undergrads they can in these expeditions, which is always fun. I mean, basically being an old fart myself, that being paired up with some of these young people and some of these absolutely brilliant young minds that are doing some of these things. They don't have a lot of world experience yet, but incredibly sharp. And it is just a lot of fun to work with some of these fellows and see what they can accomplish and how fast they learn things. This gentleman's name is Kelly, and he's a great guy. And let's see, trying to get it to advance to there we go. Before I get to the main presentation, astronomy in Australia, I don't know how many of you have been involved very much or read much about astronomy in Australia, but one of the big astronomical activities in Australia actually involves the Parkes Radio Telescope. I don't know if any of you guys are very familiar with the scope, but a lot of the fundamental science has been developed there, and it has actually played a very important role in the moon landings. This was one of the remote receiving stations used during the Apollo missions, that whenever the Earth was rotated in such a way that the stations in North and South America weren't facing towards the moon, that Parkes is one of the critical downlinks that was used to bring video to the world of the Apollo moon landings. And this is the dish that actually received the actual footage of the Apollo 11 landing, and when Neil Armstrong first flubbed his lines on the moon. It was received with this particular telescope. Now, these high resolution pictures, of course, had to be brought back. They did not transmit these, but all of the video, as terrible as it was transmitted over the wire and was received live all over the world by the Parkes Radio Telescope. There was a movie made some years ago called The Dish. Some of you might know about it, others may not. It is a lot of fun. It's definitely worth either renting, buying, or I think you can find it on Amazon Prime. What they did for this movie is they basically tried to portray all of the mishaps and things that went wrong and things went right, and how they almost missed the download link for the video feed from the Apollo mission. And some of it is fictionalized, a great deal of it's true. They have taken some other incidents and wrapped them into the same story. So it is dramatized and fictionalized, but it's a lot of fun. The instruments they show in the video are the actual instruments, as much as they could, of the era during the 60s, 1969, when they actually had the download of the video feed. And so a lot of these instruments were in a museum they have there for the Parkes Radio Telescope, and then others were basically in a back closet. Those of you who have ever worked for a government agency know how hard it is to get rid of old equipment. And many times the easiest thing to do is just stick it in the back room and close the door and don't look at it anymore, where it might sit there and molder for 20, 30, 40, or 50 years before somebody finally throws it away. Fortunately, all that gear was still there. And so they're able to recreate the actual control room with the actual instruments for making the movie. So this is what it looked like during the day. And this is where you'll find that equipment mostly today is in the museum or the visitor center for the Parkes Radio Telescope. So if you ever get to Australia, I think it's definitely something fun to look up. Anyway, back to more serious stuff, Pluto and the shadow path. One of the things about occultations, it's really hard to explain. Ever meet somebody at a cocktail party or somewhere else and you want to explain an occultation, you can say things like, well, it's sort of like a solar eclipse, but different. You know, it's a solar eclipse, but the star is not ours, it's a star somewhere else. They can be very challenging. Basically, you're looking at a distant star that's going to blink out and come back again. Here's an actual occultation video. This is of MU69, now known as Erickson, and for a while known as Ultima Thule. And for occultationists, this is a very exciting video because you've actually captured the occultation, that really remote object, Erickson, passed in front of a distant star, and that star blinks out for a second and comes back again. That is an occultation. Isn't that exciting? Now, what you do is you have a picket fence of telescopes to capture the shadow as it passes over those telescopes. And of course, we want to have this on the night side of the Earth. It can't be over water. It's got to be a clear night and some other things. And so logistically, it can be rather challenging to capture these occultations. If you have a picket line of telescopes and they're all lined up and all pointed in the right direction and in video mode and capturing like anywhere from 1/4 to maybe 6 frames a second. And each one has a very precise time date stamp on it, plus latitude, longitude, and altitude, that you can take the data and that little blink from each one of those telescope videos, and you can combine them. Here's an example of a picket fence of telescopes across the path of an occultation. This is an actual occultation that took place of MU69 or Erickson down in Argentina. But what you can do when you combine all of these different telescope data sets is you can actually get images of your object. And this is all of the kinds of data that you can actually capture from an occultation. So occultations can tell us a whole lot about a distant object, something that maybe like the James Webb Telescope or Hubble can just barely detect. And yet with an occultation, when it's backlit by a distant star, we can determine all of these different data about that object. We can determine the size, the density, shape, albedo, orbital parameters, their precise orbital parameters, where they might have been rougher before. We can actually fine tune those quite a bit. We can detect undetected moons, rings, debris fields, atmospheres, upper atmosphere compositions, lower atmosphere compositions, densities. And we could even detect if the occulting star actually turns out to be a binary or even a trinary, things we would not have known, even with the most powerful telescopes, that an occultation will reveal these things. So there's a lot of good data that can be collected from an occultation, mostly because the scientists who do this kind of stuff are really amazingly smart to figure out all these kinds of things they can learn from these objects from being backlit. Albedo is probably one of the most important things that an occultation expedition can collect. Albedo is basically the reflectivity of an object. For example, Hubble or the James Webb can detect a distant object, but it can't tell us if it's a very large, low reflectivity object or a very small, high reflectivity object. And for spacecraft missions, this can be rather critical because we would like to know if that object is really big, we don't want to hit it, or if it's really small, we want to detect moons or debris fields and rings, because we don't want to hit those either. And also, we want to be able to set the cameras with the right exposures to make sure that we have the best data within the dynamic range of the instruments, so we don't overexpose or underexpose any instrument or any camera on the spacecraft. And so albedo is one of the biggest things that we can find out for the purposes of spacecraft missions like New Horizons or the Lucy spacecraft. Typical occultation equipment is within the reach of amateurs. A telescope mount, optics, video camera, a special astro video camera. In the past, a lot of people have used analog video cameras that they've modified and done different things to them to be able to use them to collect data. Nowadays, we have really nice digital astro video cameras, like QHY makes a really nice black and white camera that has an integral GPS module. And so it is able to put a precise timestamp and GPS data as far as latitude, longitude, and altitude on every single FITS frame. And this precise timing down to the millisecond allows us to collect a really nice, tight data on the object being occulted. And also the fact that it's a nice CMOS camera, it's very sensitive. And so we can get fairly decent bit rates or frame rates with this camera. Typically, we also have a powerful laptop. I really recommend if someone's going to get into occultations, they get one with a solid state drive. They write significantly faster than spinning hard drives. They also use quite a bit less power. So out in the field, of course, you know, we want your battery to last a long time. But solid state drives do allow your battery to last a long time, especially if your screen is turned as low as it goes, because typically you don't want the screen very bright when you're out there in the dark. And so with a low powered screen turned way down and a solid state drive, that a powerful gaming type laptop can last a long time. It can last anywhere from 2 to 8 hours of operation. Typically, we always take out a printed plan, and we have all the parameters because you have software parameters are set. You have the rotation of the camera on the telescope. You have mount issues, you have alignment, you have all kinds of details. And so we pretty normally do a lot of checklists. Checklists are your friend. They help you not to forget anything. And especially something critical like click the little checkbox that says use GPS data, for example. Don't forget those little details, especially if you're cold and you're tired and you're up at 4 o'clock in the morning, that you definitely want to not miss a thing, because you would hate to go back to camp and everybody else is coming in with their telescopes and trucks. It turns out you're the one person that didn't record the data correctly. And so there's a big missing cord with your name on it. Other software, there's occultation prediction software, planetarium software, coordination software, video capture software, and data extraction software. Fortunately, all these different programs are available and they're all free. And so there's no real, if you decide to get into occultations, that you don't have to worry about trying to invest in a bunch of really expensive research software. This stuff is all available free. Depending on which planetarium program you might want, and so forth, some of those might cost, but that's a choice that you make. The program we use to control the cameras these days, there's one program only that does that, and that's SharpCap. SharpCap is by far and away the most powerful image capturing program I've used to date. That's actually very intuitive. And it is the one program right now that understands this GPS camera and will read the GPS data from the camera, incorporate it into the header of every FITS. There's a free version of SharpCap, which works just fine, or there's the pro version, which is like 30 or 40 bucks a year, which is really nice, and it's definitely worthwhile. Even if you're not into occultations, it's a great program to check out. It does a lot of good stuff. The other programs, as far as occultation coordination, or video capture software, or the data extraction software from the video, that's all available free. It's been written by various people that are involved heavily in occultations around the world. And because NASA and the European Space Union and other people that depend on occultation data to support what they're doing, a lot of times there's grant money and other things that are available for people who want to develop apps to support these expeditions, to be able to write them and maintain them. Quite often with an expedition, you'll have one town that you'll decide to go to, and then they'll identify all the spots that are available off the various roads. And so comes that night, the right amount of time before the event, that we'll deploy trucks full of telescopes or big SUVs and so forth, and then deploy out onto the roads wherever we are to get into position and have enough time to set up the telescopes, get the telescopes aligned, find the right field, and then test all the gear, and then prepare for practice runs on previous nights, and then for the big event, and of course, to capture the actual occultation. So it's a large group that you typically work with. It can be a lot of fun. This is real science. I mean, when it's all said and done, if you want to, that they'll put your name into the research papers that are published and list you as a co-author. So if you want to be immortalized in the realms of science and cutting edge astronomy, this is the way to do that. To gather the data, of course, you go out there, you got to set up your telescope, you've got to set up your laptops, and then the camera and the GPS, you have to align everything. all the stuff you normally would do. If you're an imager, of course, it's all the stuff you normally expect to do, with the exception that you're configuring a GPS unit and then configuring that to make sure that data gets into the FITS frames, and so you can collect your data. One thing that you have to be careful of is that everybody has to collect the data exactly the same way with exactly the same settings. If you don't, you create real headaches for the team organizers, because they have to go through and then manually process your data to integrate with everybody else. Where if everybody uses exactly the same settings, the same cameras, and it records it in the same way, it is much easier for them to use different software tools to aggregate gigabytes of data from 20 or 30 laptops. And we can actually see the actual shape of the objects and seeing this data come live all in the same evening after driving back to wherever our demarcation point is. Here's an example the next day when people are a little more awake. And we can see an actual occultation graph in the background there, where you see the green and the red. Those are what we call reference stars or background stars that help us to correct for atmospheric turbulence and atmospheric changes and extinction. And the blue is the actual occulted star. And so we can see where the red and the green are used to calibrate or normalize the data from the star we're interested in. And you can see where the brightness of the star drops way down, is down for a short period of time, and then comes back up again. And that is an occultation. Now, there is a International Occultation Timing Association. This is a nonprofit group. It's filled with amateurs and professionals. And for anybody who wants to get involved in occultations, this is the group to join. These are the guys that, in fact, you can go to occultations.org and read all about it. And because there's actual occultations happening all the time, all over the world. Most of them are asteroids. And this helps us to learn more about asteroids and learn about their orbital parameters, more precisely nail down their orbits. Learn more about them as far as their composition and all those things I listed earlier that we learn about these objects. And this helps us to understand these objects better, and also helps us to know which ones might become a hazard to Earth at some point in the future. And so there's a lot of real science being accomplished with IOTA, and it's a real chance for citizen scientists like ourselves to be involved. Now, NASA and SWRI, for those of you who don't know, SWRI, the Southwest Regional Institute, is one of the contractors for NASA, along with people like JPL, Lockheed Martin, and others. Now, SWRI is involved primarily in software and software design, programming, and data, and so forth, where Lockheed, of course, builds things like spacecraft and rockets. So most of the occultation expeditions that we are invited to participate in are the ones where NASA wants to learn more about an object for a spacecraft mission like Lucy or New Horizons. And SWRI is a subcontractor then that goes out, does all the analysis, finds what stars might be occulted by that object, and then finds good candidates, develops the plan, goes out and does recruiting to find people that are available, that both in and outside the federal government, who want to participate, and then go out and capture that data. And so most of the time you'll deal with SWRI directly, but all this data is for NASA. And you'll be involved in actual projects that has NASA stamp and SWRI and Lockheed Martin and JPL all over it. Anyway, the New Horizons mission is over with. Pluto is now way in the rearview mirror of the New Horizons spacecraft. And so we're going back to Pluto for another occultation. And you could ask, well, why are we still doing this? So we already have these great pictures of Pluto. We already have all this great data on Pluto. Why are we still doing occultations of Pluto? And the answer, of course, is that we're learning more about its changing atmosphere. Pluto was way more interesting than anybody guessed when we first were involved in the planning for this mission and going out and capturing the data and designing of the New Horizons spacecraft, that nobody expected quite the dynamic world that we found, as far as a really active planet lots of earthquakes, or I should say Pluto quakes, a lot of activity in the atmosphere and so forth. And so there's a whole lot that was discovered that was not anticipated. And so it's been a very exciting time for planetary scientists that have collected all this data from Pluto, from the New Horizons mission, to further study both the earliest stages of our solar system as well as understanding planetary dynamics in general. Now, since Pluto's orbit is elliptical and is currently moving farther from the sun, that the predictions have been that the atmosphere will be freezing out onto the surface of Pluto and dropping down. And there have been predictions made as far as exactly how fast the rate was of that taking place. The predictions have been wrong. Right now that the atmosphere is much more active and there's much more of it than we anticipated. And so they're very interested in find out what is the composition, what is it that's still up there? Because the atmosphere of Pluto is actually larger than the atmosphere of Earth. Part of that is because the gravity of Pluto is lower, and so the atmosphere can go farther out. Also, a great deal of the atmosphere is coming from the side facing the sun, is actual ultraviolet photons from the sun are striking the surface of Pluto. And this is basically throwing molecules of gas up into the air, which create its atmosphere. Of course, since it has a very weak atmosphere and weak gravity, the solar wind is peeling off this atmosphere fairly quickly and throwing it into space. We had a SWAP probe that detected Pluto ions well beyond and behind Pluto. This was well before the New Horizons mission. And so we know that a lot of this atmosphere is lost every year. Every time it comes in for a swing by closer to the sun, that once every 247 years, whatever the orbit the period of Pluto is, that it would lose more atmosphere. Anyway, what we wanted to do is we wanted to do another measurement of the lower atmosphere of Pluto to see what was there. And the best way to do this was with another occultation expedition. In this case, we're using the refractive aspects of the atmosphere. One of the aspects of refractory as far as refracting light around Pluto is when Pluto is perfectly centered in front of that star, that some of that starlight refract around low in the atmosphere and come out the other side as a central flash. And so the light will drop off from Pluto, and then it'll come back suddenly as a flash when the star is perfectly centered behind Pluto, and then it'll go back and come up gradually as the star moves out from behind Pluto. One thing also about occultations, you notice that this graph is sort of V-shaped, ignoring the central spike for a second. This is how we originally detected that Pluto had an atmosphere as an occultation long before the New Horizons spacecraft got there. Because normally when you do an occultation of an asteroid or some other object with no atmosphere, the starlight will drop off very square, and then it'll go and then it'll come back very squarely. And that tells you that object has no atmosphere. When the light from the occulted star drops off gradually, like it does in this graph right here, this says that's an atmosphere. Basically, the light of the star is passing through the atmosphere of the object obliquely, and then it returns on the other side. And the fact there's a central flash says that the atmosphere is actually fairly significant. And so we did not know that Pluto even had an atmosphere until occultation expeditions revealed it. This also helped us to reveal the composition of the atmosphere. We learned the atmosphere is thicker around the equator of Pluto than it is at the poles. We also learned about some of the change rates as Pluto's moving farther out. This atmosphere is diminishing. And occultations are also how we discovered the 4 moons of Pluto. We discovered that before New Horizons was even out there, which is a good thing, of course, since we don't want to hit any of them. So all these things we discovered about Pluto long before the New Horizons spacecraft arrived there. For this particular expedition, the prediction was that the shadow of Pluto by that distant star was going to cross over New Guinea and Australia, but we wanted to capture not the occultation of the entire planetoid or dwarf planet so much as we really wanted to capture the central flash. And so the solid blue line there was the part of most interest. We wanted to have a picket line of telescopes just over that central blue line, by maybe give or take about 40 kilometers, maybe 50 kilometers. The rest of Australia, we didn't really, and Indonesia and New Guinea, we didn't really need that. We already had plenty of data that would, there's nothing new we could learn in those areas. But the central flash was very interesting to us because that would tell us an awful lot about what's happening in the lower atmosphere of Pluto, which is something we cannot detect from Earth without sending another probe out there. Typically, for a prediction that people at SWRI, they tell the various software programs they've collected, we can actually also get free copies of these software, what object we want to track, and the software will analyze that object over time and determine if it moves in front of any good bright enough stars in the background to create a good occultation. We set those parameters and the software will chug away for a few days and it might pop out a bingo or two. And then humans will go back and verify that the software correctly identified a potentially good occultation. Some of the other things involved, some of the parameters, is that it would depend on the composition of a star as far as what the light spectrum of the star was, because we're interested to see certain frequencies absorbed by Pluto's atmosphere. So we want to make sure that star has enough light of the right frequency that spectroscopy would be able to work. So we verify the events, we verify them again, we go through and apply more parameters and check it, and then there's another verification step because we don't want to do a big $1 million expedition and finds out we didn't get what we needed or we went to the wrong place. It has happened. Not so much with Pluto, since Pluto's a fairly big object, but some of the Kuiper Belt objects like Ultima Thule, which is extremely tiny, way beyond Pluto. And we went on a number of expeditions to try to capture the shape and parameters of Ultima Thule. And we missed 3 times before we finally got it. So it was a tricky one. Anyway, our understanding of Pluto has increased significantly in less than 20 years. I mean, in 1993, that is the best image we had of Pluto. Then in 2015, with the New Horizons mission, of course, we know so much more, and we can now see Pluto the dog. Some of the challenging aspects of an occultation expedition, of course, is safety. If we're going to go to a different country, we want to make sure it's a country that's going to be friendly to us and not be at risk of our lives. We want to go somewhere where the weather predictions are going to be good. We don't want to go somewhere where it's a jungle and there's no roads and the weather's always terrible. We're going to carefully pick the equipment we need to take since it has to be portable. Some of the equipment that SWRI owns is 16-inch Skywatcher Dobbs. Takes 2 people to set those up and take them apart safely. One person might be able to do it, but they're very heavy and it's much better with 2 people. Some of the smaller scopes, when dealing with brighter stars for occultation stars, they have some C11s, some CPC11s, and they also have some 8-inch scopes that are usable for occultations if the occulted star is bright enough and gives us enough light to work with. Otherwise, we have to go to the 16s. Whenever there's a professional observatory somewhere along the path, that we always try to get them involved if we can. But of course, they can't go anywhere. So they're going to capture a specific chord because that's the only chord they can capture. And then we'll supplement that data on either side with portable rigs. There's a lot of stuff that goes into an expedition. They have to make this, the leaders have to make decisions as far as the size of the internal team, the size of the external team, which are mostly going to be IOTA members. So if you're going to want to be involved in expeditions and get free trips around the world, I would definitely suggest you join IOTA. The duration of the expedition, most of these are pretty fast. We'll get there 3 to 5 days before an event. We get collected, we get checked in, we get our rental vehicles. We do 2 or 3 practice nights, and it's event time, and then the next day we're packing up to get out of there. So things do happen pretty fast. So you got to be a little bit organized. You can't, if you're going to go someplace wonderful in the world like northern Spain, you have to be organized enough to know how much time you have to go be a tourist and play around without affecting your responsibilities to the team. After they have all of the budgets estimated, then there'll be the proposal. Now, this is a picture of Dr. Alan Stern. He is the principal investigator of the New Horizons mission, the Pluto mission. And he is the guy who's still involved with the Pluto missions as they're still processing the data from the New Horizons mission that they collected. He's also the guy that will go for, now it's not at a nice podium like this, it's more likely a conference room where he's being hammered and challenged as far as why do you want to go do this new occultation expedition? And what are you going to know? What justifies this expense of money and so forth? And can you tell us why, what you're going to do with that data? How is it going to benefit NASA? How is it going to benefit humanity to spend this money to collect this data from this occultation? And so someone like Alan or somebody else will go and make that presentation and try to persuade the budget people at NASA to break loose with the money to go perform this particular expedition. Typically, the assigned budget is a little bit less than what anybody wants, but that's sort of normal. And so, in fact, an awful lot of the IOTA people will do these expeditions, and they will let SWRI and NASA pay for their plane tickets and things like that. But things like meals and so forth, they don't even bother to exhibit them for reimbursement. So a typical unit for some of these expeditions will be the 16-inch go-to Dob. These things are a bit of a pain. They're not a precise telescope. Finding the right field can be challenging. Balance can be a challenge. Set them up, they do break. Having spare parts in expeditions is important. But overall, they give us a really good bang for the buck as far as being able to collect the photons. And if we can live with the other limitations, they do a fairly good job for us. For this particular expedition, our fearless team leaders were Leslie and Elliot Young. They are brother and sister. They both live in Boulder. And they both are absolutely brilliant scientists. If either one of you, if anybody here has met either one of them, you will find them to be very amicable and very pleasant people. They're a lot of fun to be around. And they're always full of really great occultation stories involving creatures or things that go bump in the night. One occultation I did in Texas, that I bought a pair of tall, sturdy cowboy boots just because of the propensity of rattlesnakes to look for warm areas like cars parked in the desert, and will congregate under these vehicles for warmth. And if you're walking up to the car and you get too close to something like that, it may not go well for you. So I would gather these. I went and bought a pair of really stout cowboy boots at Boot Barn in Texas. And I've actually taken him to Australia with me too, because a lot of the same kind of challenges existed there as far as, I mean, I think every snake that's there is poisonous. And besides the scorpions and all these other crazy creatures around there, when I set up in Texas, that there's wild cattle running around in the areas out there. And so when I was setting up, some of them came over and were curious to check me out. And so all night when I was at the telescope and it's pitch black, because I can't have any light hardly around the telescope while I'm collecting data, I was expecting any minute to have a big wet cow nose in the back of my head or in my neck. And fortunately, it did not happen, but I was prepared for it. So I wasn't going to be startled too badly if it happened. This is a picture down in Catherine, just south of Darwin in Northern Australia. This is where our central operation setup was at. And we're having a talk, we're previewing what we're about to do that night. Now that's Leslie giving the talk. In the background, in the red shirt there is Mark Bowie. Mark Bowie is actually over Leslie, and he was grooming Leslie to take over some of the expeditions because he's only one guy and they wear him pretty ragged running these big expeditions. Mark's got tremendous experience of bringing together groups of anywhere from 20 to 100 people, all with very dynamic personalities sometimes, smart people, and bring them all together to do an occultation expedition. And he's got phenomenal organization skills and phenomenal science understanding. He knows how to do an occultation. He knows all the nuances. He knows where he can fudge and where he can't. He knows how to bring the data together, and he's really good at when things go wrong. He's the guy you want at the head of the ship. He'll figure out how to get you out of trouble. And Leslie, sorry for that beep there if you heard it. But anyway, Leslie and Elliot are basically working under Mark and learning a lot of what he does and how he does things, so they can run the expeditions and basically take some of the burden off of Mark. For this particular expedition, Mark talked to various academic institutions in Australia, and the Charles Darwin University was happy to host us and be involved and provide different student volunteers to assist us with local logistics. Sometimes you got to find tables or chairs, or sometimes you have to find battery packs, replacement parts, and so forth. And so a lot of the logistics will be assisted from local people. And they told us that we could stay at their rural campus, which is a farm research campus just north of Catherine. And it was pretty central to our expedition. So it was an ideal place for us to set up. When we're traveling, we don't always get the Taj Mahal as far as places to stay and materials. This is the campus here. They had fields and fences and corrals for horses and cows. And at night, there was wallabies everywhere. I mean, you basically had to be careful driving around. There was an awful lot of wallaby kill on the road, which I did not take pictures of, so I don't think you needed to see those pictures. But the common areas were plain, very clean, but plain. And but you had to be aware that you never left the doors open anywhere. Between snakes and other venomous critters and monstrous spiders and whatnot, you never left the doors unlocked. And so they gave us all this little RFI bracelet to wear that would open doors, because every time you went in and out of a door, you had to make sure that door closed and locked and clicked, so things like this didn't wander into the buildings. This is my room. You notice that the metal screen on the outside of the window there, they told me that was to keep certain kinds of critters out. I wasn't sure what those critters were, but I took their word for it. It did still feel a little bit like a prison in some ways, but overall, I mean, it's just part of the adventure as far as all the crazy places you get to stay and things you get to do. This is one of the 16-inch Dobbs, loaded in various custom cases and loaded in the back of a truck. One of the challenges of car rentals is when we went to Argentina, that the only vehicles they had were these Toyota trucks, were four-wheel drive, but they were manual transmission only. And so there was definitely a big, strong call out for who can drive a manual transmission, because almost all of the college kids couldn't. And so us old farts that had lots of experience with manual transmissions were able to say, well, I can drive a manual. So we became critical to the whole expedition, because they made sure that all the people who could drive a manual got the trucks, and all the kids that couldn't drive a manual were the assistants to the people who were driving the trucks. There is another challenge in Australia, though, because you're on the opposite side of the road. And that is, of course, you're driving on the opposite side of the road. What I discovered is that you'll worry a lot about this. When you're first there, you worry and you do okay. You actually can manage to stay in the correct lanes and do your thing. But the real danger happens on the third day. And what that is, that's the day you get complacent and you think, hey, I got this. And next thing you know, you're accidentally on the wrong side of the road. And you go, oh, crud, and you whip over to the side. And so you got to watch that complacency, because it will definitely bite you. This is some of the facilities we had in Darwin when we first landed, because first we flew to Sydney, then from Sydney to Darwin. Then from Darwin, we got all the rental vehicles. Then we departed for Catherine. And from there, we set up our base camp and then did our expeditions from there. So this is just some photos from Darwin. Pretty hotels, pretty sites, a little bit touristy. That changed radically when we went to Catherine. That was definitely the Outback. You guys ever go to Australia? One of the things I want to tell you about is if you get a chance, check out Pie Face. It's a little fast food kind of place, maybe just a kiosk, but they have meat pies there. And some of the meat pies are just absolutely stupendous. If you've ever had a really good meat pie, you might know what I'm talking about. If you haven't, and you get a chance, try their curry meat pie. They are absolutely wonderful. Every time I go to Australia, I always get on Google Maps and find the closest pie face so I can go check out and see if I get myself a curry pie. They are great. You got to be careful in other countries. Sometimes some words that might be highly offensive here are not over there, or vice versa. You might say the wrong word there that is not offensive here. I will not use the word, but these kinds of souvenirs were everywhere around Catherine and Darwin. And basic plays on words, and NT is for the Northern Territory, which is this entire area. And it's like see you in the Northern Territory, or it plays on words like care, understanding, nurturing, and so forth. And they think it's a lot of fun. In fact, they think it's even more funny that Americans are so traumatized by the word. So that's one of the things you need to do before you go anywhere in the world is check out, make sure you understand the local vernacular as best you can, local language, and avoid mistakes. Another example is in Russia, that the word yup is an invitation to casual sex. So you have to be careful. You see the Russian yup, he looks both ways and he goes, da. That's not a good thing. You don't want to go there. And, the Catherine area is actually rather beautiful. It's a lot of desert and flat ground, sort of sparse, but there are some places where there's some rivers, and it's a very beautiful area to visit. So if you go someplace like this and you get a chance, you definitely want to get out there and explore a little bit. Just staying on the highway, you'll miss some of the best things. For this particular expedition, you can see that there are some other telescopes that decided to set up in other parts, but they aren't anywhere close to the central flash, which is in Northern Australia. The red and purple lines there, those indicate sunrise. And so you're trying to find some places between sunset and sunrise, usually about halfway if you can. That's also close to the central line of the occultation. And since we're after the central flash, that we were focused in a very tiny area of Northern Australia. Actually, the area we're focused on, because so many asteroids and trans-Neptunian objects are so tiny that their shadow is going to be about as big as the central flash area of Pluto. Pluto is big and slow by comparison to many of the other objects that we chase with occultations. So we zoom in on the shadow path here, and that central blue line is the most important. So naturally, the most important scientists clustered around that line, and all the rest of us were sent either north or south of that line to capture other portions of the central flash. This is a picture of the cord. One of the things we'll do in an occultation is we will use Google Maps, and we'll look at our cord line where it crosses highways and roads and so forth to determine where we're going to set up. For example, in this picture, we could set up on the Stewart Highway or just off of it, but then you run the risk of headlights, of truckers that go by and things like that, or maybe the cops will stop by in the middle of the night and wonder what in the heck you're doing. And of course, they've got spotlights and they put them all on you. And if you're right at the moment of the occultation, they can ruin everything. By the time you try to explain to them, turn off your lights, it might be too late. This has happened. So you start here and you look and okay, we got that spot. We got two other side roads here, maybe a third side road we could hit that are a little farther away from the lights and away from the road. Maybe they're better. But as you zoom in, you go, okay, I'm looking at that. Is that a gate there? Can I even get onto that road? Or sometimes the satellite photos are old enough that what was once a road is no longer a road. Or what you think is a road is actually a railroad track or maybe a cow path. And so you'll do all kinds of reconnoitering using Google Maps and photos and everything. And then what you'll do is on your practice stage during the day, you'll drive out there and check it out and find your spot. And try to find some place that's away from the road, away from potential lights, but also give you a clear view of the sky in the correct direction and so forth. So on our practice nights, we'll actually don't necessarily go to the spot we need to go. We'll go right there on the campus. Everybody sets up, and then people like Mark Bowie or Elliot and Leslie will run around to all the different groups and see how they're doing. This is where we'll find if we have a bad camera, or we have a defective telescope, or a defective battery pack or something else, or camera settings are wrong. And then the experts are able to help all the other teams go through their gear and our setups to make sure everything's running perfectly. Of course, things can go wrong for other reasons. This is one of our practice nights. You can see the weather moved in, and we had some beautiful stars in the Milky Way up there, and plus the large and small Magellanic clouds, but we had clouds that moved in as well. So it became rather challenging. Makes for a pretty picture though. Here's another picture of the teams and so forth working with the clouds. This worked well for practice nights. Typically, we do 1 or 2 practice nights at your location after we have the all hands grouped together, like the first night or 2, and where you've worked through all the minor problems, hopefully, and so you're deployed out away from everybody else at your actual location to see how it works. And of course, there's also some biological problems that can challenge you. This guy was right in the middle of the campus, actually, and this snake was literally like 15 feet long. You know, some kind of a king brown snake, I believe I was told. Very deadly, very poisonous, who lives in this drain right in the very middle of campus. Another interesting thing is right at sunset, you'll find a whole lot of creatures flying in the air. And it turns out they're actually bats, not birds or owls, but bats. And you'll see hundreds of bats in the sky flying around just at sunset. And they're up there all night long. And they will fly through your occultation video at times. And so different stars might vanish for one frame and come back again. And of course, there's one of the wallabies. These guys, you only saw them at night, and you only saw them in your headlights as they bounced away from you. But every so often, there'll be someone who's caught in a highway in an unfortunate moment. But also, if you're away from your gear and not paying any attention to it, you're back at the truck messing around or the car, that these guys can come up and do things like nibble on your cords and stuff, which can be a bit disadvantageous. This is the little GPS screens when you load Sharp Cap and you've got the GPS set up and it's collecting data and getting a lock on the sky. It's very important that you make sure that your GPS goes from partial data to locked. Otherwise, the time may be up to 20 seconds off. The way GPS satellites work, that it takes up to about at least 20 seconds. In fact, in some GPS, up to 20 minutes, that you have to let the GPS run and idle before it collects all the ephemeris data that's available from the satellites to compensate for missing satellites or to compensate for any changes in the orbital constellation of the GPS satellites since your GPS last saw the sky. And so it's important to, and if you forget to incorporate the GPS data, of course, then your data is effectively worthless. After you got everything running and you've got Sharp Cap running and you got your telescope and your camera in place and you're about to focus, the next thing you have to do, of course, is collimation. And you can see here, this scope is not very well collimated yet. And you use the camera to do that. And with 2 people, it's easier because I have one guy at the back of the scope and the other guy on the control to pointing to the telescope and then also on the laptop looking at the screen. A lot of little things to get right. Now, one of the greatest challenges of occultations typically is finding the field. You'll get a nice, beautiful map like this that shows where Pluto or whatever object you're tracking is moving through the sky. And the circled object is the stationary star that's going to cross in front of it. Of course, the reality is you get a map like this. And you can see the central star there with a small star off to one side of it. And that is the occulting star, and this is the star field you have to find, and this can be a bit challenging. and you zoom in and it's still really challenging, especially when your laptop screen looks like this. And to make it even better, this screen can be flipped left to right from your chart, or up and down from your chart, or left and right and up and down from your chart. And so you have to be able to recognize patterns in the stars and recognize if that pattern's flipped up, flipped down, flipped left, or flipped right, or flipped both. To find the star field, so you are on the correct star field to capture the occultation. Now, this is one of the steps that gives most people the most grief, is finding the field. One of the things that SWRI has done more recently is they've incorporated plate solving. And on the bigger scopes, they're able to successfully have the scopes in the ASCOM and the laptop do plate solving. And this solves about 95% of all the challenges we've had in the past as far as getting on the target star and being able to, with enough time, to record both before and after the event. So we can have other stars in the field used as our calibration stars to compensate for atmospheric extinction and so forth. The other challenge, of course, is you're looking at the screen in the dark. You also look at the telescope in the dark. And we're looking at, in this case, Kevin's looking at his phone because this is where he stored the parameters for setting the camera. So we have to look at these bright screens and then look at the telescope and back and forth, and not trip over any cords. And it can be a bit of a challenge. You also want to, of course, face this laptop screen away from the telescope so we don't have any of this light falling on the telescope, being collected by the primary or secondary mirror and brought into the camera. After the data is collected, we go back to our HQ, or our demarcation point. The data is then brought on thumb drives and it's aggregated quickly by the team leaders. We can see if we got anything. This would be a video of the central flash from this particular expedition, but I tried for several hours to get this video converted into a format that PowerPoint can understand and was unable to do it. So unfortunately, I don't have a video to show you. It is on the internet. If anyone was interested, you could ping me afterwards and I'll share it with you. It is just about as exciting as the other occultation video I showed you, just to warn you. So it shows the star going out, and a flash in the middle, and it coming back again. So things that might make occultationists really excited, but typically our spouses, not so much so. But here is the data extracted from, this is the actual central flash recorded from one of the scientists at the very center of the occultation path for Pluto. And we caught the occultation, or the central flash there, and they were able to derive useful data from the amplitude of the flash, and also as the spectrometers, changes in spectroscopy of the starlight showed us what light was being filtered by the atmosphere, which told us about the composition of those gases closest to the surface of Pluto. Then, of course, the next day, everybody's really tired from being up all night and up all day for the previous 3 to 5 days. But we still have to wrap up all of our kits, and we have to have, in other countries, we usually have to have somebody from some state department there, local state department, to confirm we're not shipping things that we didn't previously bring with us to that country, and check for contraband and so forth. We're allowed to put these things in semi-trucks and then send them off to a barge to get back to America. Then we all say our goodbyes until the next expedition. And as we all get to watch bad videos on various flights, this is a video, this was a Hawaiian Airlines flight. For this particular expedition, I was lucky because I was one of the closest people to home after the expedition. So my flight was much shorter than a lot of people's getting back home. But we still had to suffer some of the lame videos they have on there, which I guess is still better than nothing. And after it's all said and done, the team leaders go back and they go through all the work to reduce the data, collaboration, and so forth, and list those people who want to be listed as co-contributors, and then get scientifically published. And all of us are given the option if you want to be listed as a contributor, as a co-author or not. Typically, I don't feel I've done enough of the contribution for all the work that they do that I choose to be a co-author, but they do offer that to anybody who helped, that they will be happy to add your name as a co-author on their papers. So, and that will immortalize you in a way. So that's the end in a way. There will be more occultations of Pluto because they will want to measure the central flash again in a few years and measure how much the atmosphere is changing as Pluto moves farther away from the sun. One of the things they've learned so far is the atmosphere is not dropping out nearly as quickly as they predicted. The atmosphere is persisting and they don't know why yet. And that's, of course, for a scientist, that's a very exciting thing to know that they don't know yet. And so they're interested to find out why. And so there will be more occultation expeditions in the future. Hard to say where they're going to be. It depends an awful lot on budget. Pluto is big enough, it occults parts of the Earth at night all the time. But just, you know, of course, we have to make sure it's a friendly country that we can safely go to visit and one that will support what we're trying to do. And all the other parameters that go into those kinds of expeditions. But there'll be more expeditions. And for those of you that are interested in occultations, you're going to some of these crazy expeditions, either for New Horizons or for the Lucy spacecraft mission, which is some of our bigger expeditions right now, that definitely I want to join IOTA or contact me and I'll get you into talking to the right people. And it could be that the equipment you already own will do nicely for occultations in your area. And we'll prepare you if you want to be part of some of these big occultations for NASA/SWIRI in different parts of the world. And that pretty much wraps up my presentation. I'll take any questions. Let me stop my screen share here. And so anybody have any questions on all that? Everybody awake?
I have heart palpitations thinking about reducing that data and looking at those screens. I have no questions in the chat at this time. Anyone want to unmute themselves and ask a question?
Yeah, I just have a comment. I remember seeing the occultation of Ultima Thule. What do they call that now? Arathol or
Arakoth.
Arakoth, yeah. And it showed two lobes, the occultation. And a lot of people were skeptical about it. Was that real? And then when they visited, there were two lobes. It was like, wow, it actually caught that. And that really blew my mind that, wow, these occultations are really precise. You know, wow. It's just.
Yeah, some of the occultations of, go ahead.
I said it, when done right, it's real science.
Yeah.
Jeez.
Yeah, one of the other challenges for the scientists in doing these occultations of asteroids is asteroids quite often are spinning. And so one occultation expedition will capture one shape and the next expedition captures a different shape. And then using software in 3 dimensions to try to reconcile the different shapes from 2 or more occultations is pretty exciting. And so far, every prediction they've run where they've had like 3 or more different occultations and shapes that they've had to try to reconcile into a 3-dimensional shape, they've been very accurate. So it is it's pretty amazing what they're able to do with this data.
Really? Jeez. So Chris, do you bring your own telescope to these or does IOTA provide a telescope for you or how does that work?
IOTA does not provide telescopes, but SWIRI/NASA does.
SWIRI. Okay.
Yeah, basically when they're collecting for data, it helps them a lot if everybody uses exactly the same equipment, set exactly the same way. That really helps them to aggregate the data quickly.
Okay.
If you have a bunch of really diverse telescopes with different depths and gains and different cameras and different programs for capturing the data, it can make it a rather manually intensive effort and take a lot longer to aggregate that data into one data set.
Mm-hmm.
But for IOTA, they say that at any given time, there might be 12 really good asteroidal occultations near anywhere that you happen to live. And so if someone wants to get active in occultations, that you may have an occultation a month just in your own backyard. If you want to travel, there'll be a lot more. In fact, some people will take 2 to 4 telescopes out and along with their spouse, set them up along, make their own picket fence across the path of an asteroid and capture 4 chords of that asteroid. And if you have other people out there as well, just with IOTA, you might get anywhere from 4 to 20 chords for a particular asteroid. And all this data is aggregated, and then different scientists, especially undergrads and so forth, their grad students, have access to this data. And there's an awful lot of interest in science and research papers they can do with data that's been collected for them by IOTA. And of course, with SWIRI, we're typically doing more challenging things. We're doing Jovian asteroids way out, both before and after in the orbit of Jupiter. So they're quite a bit farther out. And so those are a little bit trickier because the object's farther away. The shadows are still about the same size. If your shadow is about 95 miles across, then your asteroid is 95 miles across. The occulting stars are so far away that the photons from that star are traveling virtually parallel when they reach the Earth. And so the shape of the shadow is the shape of the object in whatever orientation it is at that moment.
Okay. Jeez.
The Dobsonian telescopes are tracking, right? You have it on the tracking platform?
Most of the time these days, yes. I mean, the average occultation mount these days is a nice go-to mount. I have a number of big mounts I have here at home locally. Being that I live on an island, I can't travel too far, and so I don't really bother trying to travel too far. So I have big scopes I use here. But for traveling, I have some more portable scopes and portable mounts. I have a couple of strain wave mounts, the Rainbow Astro RST 135E, and also recently picked up a ZEWO AM5 to play with. And these can handle, I mean, basically they can both handle a C11. And a C11 with a hyperstar combined with the QHY GPS camera, the 174M-GPS, is a pretty formidable little occultation rig that I can put in cases and take in airplanes with me. And so that's fun to get out. I have family in the mainland, and also there are times when it's fun just to get out and get my RV off the mainland and then go around and do occultations for a while. But that's a pretty good combination, 11-inch with Hyperstar and the GPS cams, a pretty formidable combination for doing portable, serious occultation data captures. Typically, the bigger the aperture, the dimmer the stars you can work with as far as an occulted star. But I would say the vast majority of really good occultations can be done with an 8-inch scope. I mean, of course, a 16 will do so much better, but an 18 will work, or an 8 will work.
The ZEWO AM5, Chris, is the one I had in your driveway.
Okay.
Of course, I only had a little 92 millimeter stowaway on it, but imagine it will handle up to a C11.
Wow.
I wouldn't put a C14 on it, but many images I've seen with 9 1/4, but a C11 can be done.
Yeah. Good.
Are you using the counterweight bar with the C11?
The C11, I'm definitely using the counterweight bar and a couple of counterweights. Basically, and you can do alt-as with these videos. The image may rotate, but it doesn't matter because frame to frame, what you're measuring is the amplitude of stars. And basically, you're watching the target star drop and come back and using other stars in the field as your calibration reference to adapt for extinction and so forth. But yeah, alt-as works fine. And so on the RST 135E or the QHY AM5, that I run them on alt-as, and I do the counterweight bar, so I can put counterweights on the other side, so I can keep the center of mass of the whole mess pretty center on the tripod of the pier. If you don't do that, you can run over the edge. And plus, the C11 would be a little bit too big for these mounts. Your batteries would be straining a bit. You'd probably handle it, but I think things go better with the counterweights, especially with safety and keeping everything centered over the tripod of the pier.
I see that Bill D is here tonight. He is one person I thought that would be really eat up this kind of presentation. Are you ready to do some occultation in your backyard and some travel, Bill?
I might. I think I would like to try it. in my backyard and see how it goes. I was really interested. Is Pluto or objects that are within the solar system most likely to have that central flash? I mean, it just seems like the further distant objects would have, it wouldn't be so noteworthy. I'm not sure.
Yeah, a central flash is a critical artifact of an object that has an atmosphere. If they don't have an atmosphere, they don't have a central flash.
Okay, makes sense.
Yeah, so with asteroids, it's based rotation.
What'd you say, John?
So with asteroids, it's rotation and shape and albedo that you're looking at a lot.
Hi, Chris. Jeff here. I was just wondering if you could comment a little on, you mentioned the spectroscopy. So you want a star with kind of the right spectrum, so it'll be supplying light perhaps in a wavelength where or you think the atmosphere might have a chemical that would absorb it. I'm just curious if you could say a little bit more about the spectroscopy and how that works down at the telescope optics software end.
But typically, if you're going to do spectroscopy, of course, you have a spectrometer on the telescope instead of a camera. The other way we do that is by using the QHYs with different narrowband filters, that they can look for just specific frequencies and develop light curves of those frequencies. We've tried this a lot in the past, and that's a lot more difficult. Quite often, if we're going to do spectroscopy, we try to get a really big go-to Dob to the center line, something in 24 inches or bigger, or 32 or something, to get enough light to work with that. Working with the smaller QHY cameras and filters makes finding the field a lot more difficult, because when you put these narrowband filters on the cameras, a tremendous number of the stars in your field are going to vanish. Unless you have a finder field that matches that spectrum, you don't see the stars the same way, and you can't find things. And we've wasted a lot of time in the past trying to do that. And so currently the best way to do that is they have various spectrometers at SWRI just for this, and they put them on these bigger scopes that have an awful lot of photon gathering capabilities to have enough light for the spectrometer to work well. So it's theoretically possible with the smaller cams, but we've had a lot of problem with that. Probably if we came up with finder fields that were also filtered, that would help, but nobody had ever had the time really to do it that way up to this point.
Is there enough difference, say in the pole versus the equator atmosphere, that on a different chord you could see different composition? Is that something that's been done?
Now, that's one of the things they were working on this particular expedition to observe Pluto, is to have multiple large scopes right at the predicted central flash portion. Then we had all the monochrome cameras on either side to fill out the wings, so to speak. And they were able to capture good data, so they were very excited. And since I was in one of the wing telescopes using the QHY cameras, I wasn't directly involved with the spectrometers and the big scopes to see exactly what they were doing. And because of the constraints on how long we're not there, that I wasn't able to get an awful lot of detail about that. People like Leslie Elliott Young are very accessible. If you go to the SWRI website, you'll find them, and you'll find their email addresses and their phone numbers and so forth. And if you contact them, they will fill you with more information than you want.
Okay, thank you.
This is good. Keep it up. Any questions are open for people who are curious. I have none in the chat, so you're the next person to raise your hand.
Well, I hope you guys liked the presentation. I hope you found it entertaining, and maybe one or two people will decide to try an occultation. I think that'd be really cool. I'd love to see more occultations out there. It's a lot of fun to have friends around the world that people you get to see maybe 1 to 3 or 4 times a year and come together for these expeditions. And it's always fun. And you're always meeting really great people. Everybody that goes to these expeditions are exceptionally bright people. And you're always meeting really interesting people with very exceptional backgrounds and stories. And so they're quite an experience compared to your average trip to the grocery store.
Hmm. Yeah. When I joined IOTA, it was back when there was a hiatus in camera acquisition because Jack's camera, I think it was, were all supposed to be modified video night cameras for security cameras, and you had to modify them for use for IOTA, and none of the kits or the parts existed because they had become obsolete. So it was a free-for-all with what the equipment. There was no standardization like there is today, and I am completely passive member. I had the software installed on an older laptop, and I don't even think I have it anymore. Occult 4, I think it was called. Of course, SharpCap has changed the world for that kind of work.
Yeah. Did Chris just drop off, John?
I don't think so. I think he just went to avatar mode.
Oh.
I don't know.
Oh, there he is. There he is.
Reconnecting.
Oh, he's reconnecting. Okay.
Yeah.
All right. All right. If nobody's got any more questions, then we're going to go ahead and continue the meeting. Thank you, Chris.
Well, let's give Chris a huge ASGH thank you, because that was above and beyond what.
Thank you, Chris.
That was something else.
Well, hope you guys liked it.
Oh, that was fascinating.
My laptop just died a minute ago, so I jumped on with my phone.
Yeah.
Good thing it wasn't in the middle of
we noticed you occulted for a minute there.
I don't know. This laptop has not burped once in 5 years, and suddenly, right now, it burped, and I have no idea why.
Wow. Well, I got to know an engineer you can call.
Yeah. There you go.
Chris, thank you for taking the time. When you mentioned it at the WAC meeting, I just so, please, would you please? And I'm glad you took the time to do it.
Yeah.
All some of these slides.
Yeah, much appreciated.
Okay, I'll see you guys later.
All right.
Take care, Chris. Thank you for doing it. Wow.
All right. Anybody want to make? Okay. All in favor of adjourning?
Sorry, Chris.
Aye. All right. The motion carries. See you next month.
10:05 p.m.
There you go.
What you got here? Hey, little buddy. New Year's resolution. Nice.
Okay. All right. Thank you, everybody.
All right. Think hard about. Hey, you guys, you missed out not doing a dude heater presentation with Dave. The stuff was pretty cool.
Yeah.
The meeting for all. Good night, everyone.
Good night.
Good night.
One.